Welcome to this lesson on iterative processing. As your programs execute, there's going to be times where they need to repeat a specific number of statements. For example, they might need to read every line that's in a file, or they may want to display the values 0 through 10. When your programs repeat statements, they're said to do iterative processing. C provides 3 iterative constructs: the for loop, the while loop, and the do while loop. In this lesson, we'll take a look at each. The while loop is similar to an if statement in that it's going to have a condition that it evaluates to see, should I do the loop or should I stop doing the loop? Let's just jump in and look at one. We'll look at the while loop in more details later. But in our first example, we're going to declare a variable called age and give it the value 1. And then as long as age is less than 21, we're going to loop, incrementing age. And so our loop should count 1, 2, 3, 4, 5, 6, all the way up to 22, at which case our loop ends, and we'll display the first statement that follows the loop. In this case, we'll print out what the ending age was. Let's go ahead and run this. And it displays our ending age is 21. That's because once age was equal to 21, our condition failed because age is not equal to 21, and C continued our processing at the first statement that followed the loop. Let's look at a similar program. In this case, we're going to initialize age to 1, but in our loop, as we increment the age, we're going to display the corresponding value, and then we'll display our ending age again. And so let's go ahead and run this. And sure enough, you can see that our first iteration of the loop, age is equal to 1, our second, it's equal to 2, and this repeats until age is finally equal to 21. If we scroll down and see our output, it shows our ending age. Now we didn't execute when age was 21. We didn't execute the printf statement that showed the age because our while condition failed. Our condition was false, so our loop ended, and then it displayed our ending age. We're going to look at all the loops and find out that when we want to increment values, the for loop's a little bit better. But I just wanted to get you a feel for iteration. We're repeating a number of statements until a condition is true. And so we said C has 3 iterative operators: the while, the for, and the do while. In this program, we're going to take a look at each one of them. And again, we'll look at each in detail. But I just want you to get a feel that each one allows us to repeat a statement. Our statement can be a simple statement, or it's just a single statement, or it can be a compound statement that's enclosed in braces, so we can do multiple things during our loop. So in this case, we have a variable called count. It's going to control our loops. And so our first while statement says, as long as count is less than 100, display the value of count and increment it. So we're going to go 0, 1, 2, 3, 4, all the way up to 99. Once it increments it, it's 100. 100 is not less than 100, so our loop will end. We then have a for loop, and for is great for looping through a series of numbers, a series of letters and things. And so our for loop initializes the variable count to 0, then performs the test. Is count less than 100? It is. So it then does our print statement. Once the print statement executes, our code will then go back up and test again. Finally, our do while loop does the statement at least one time and then tests, should I repeat the series of instructions? So let's execute this program. And sure enough, we see the values 0 through 100 repeated several times. The first set of values is declared or displayed by our while loop. And so it's looping, and it's using count to control the loop. And with each iteration of the loop, it's printing the value and then incrementing the value. Our for statement has multiple components. It has an initialization part, a test part, and an increment part. And so when our loop starts, it initializes count to 0. It does that one time. Then it tests the condition. Is count less than 100? It is, so it executes the corresponding statement. After it executes the statement, it goes up and does the increment portion of the loop. That's where it says count plus plus. And so it's going to then test Is count still less than 100? Repeat the loop. It does our print statement, goes up and does the increment portion, count plus plus. And then our do while loop, we first initialize count to 0, and we're going to automatically do the print statement. There's no test first, it just does the first statement. After it does the statement, it tests to see, should I repeat the statements? As long as count's less than 100, it's going to go back up and do the printf statement again. And then we'll repeat that until count is finally 100 and our loop ends. And so our C4 statement is ideal for repeating statements a specific number of times. And again, the for loop has three parts: an initialization, a condition test, and an increment. And then beneath there are the statements that we want to execute. So let's look at the first one. We've got a variable called count, and in our initialization part, we initialize it to 1. The initialization part of a for loop only gets executed when the loop begins. And then after that, it never executes again. Then we have our test. Our test is performed with each iteration of the loop. In this case, we're testing, is count less than or equal to 10? If it's true, then we execute the corresponding statement, print the value of count. After we execute our statement, we go up and do the increment portion. We're incrementing count by 1. Following the increment portion, we retest, is count still less than or equal to 10? If it is, we perform the statement. So in this case, when we run this program, we see the values 1 through 10, just as we would think. In this case, our loop is a little bit different. We're initializing count to 100. Once we do the initialization, we then test, is count not equal to 0? Well, 100 is not equal to 0, so we're going to execute the statement that follows, print the value of count. We then go up and do the increment portion, which in this case is saying subtract 1 from the value count. It becomes 99. So we do our test. Is 99 not equal to 0? Well, it's not, so we print the value. We go up and decrement it again. And we repeat this process. So when we run this program, sure enough, we see our for loop count down from 100 down to 1. Once count's equal to 0, our loop ends. Now when we use a for loop, we're not constrained to using integer values. In this case, we have a variable called letter. We're going to initialize it to the letter A. And as long as letter is less than or equal to Z, we're going to print its value. After we do our print statement, we go up and increment it, and we test again. Is B less than Z? Yes, print it. Is C less than Z? Yes, print it. And so let's go ahead and run this program. And sure enough, we see the letters of the alphabet, A through Z. And then again, our initialization, sometimes we'll count up, sometimes we'll count down. In this case, we're initializing count to 100. We're saying count's not equal to 0. Do the statement, so we're going to print the value of count. Then we're going to do the increment portion, which says subtract 1 from count. And so when we run this program, sure enough, we see the values counting down. Now we've learned that a simple statement is a single statement, and a compound statement is one or more statements enclosed within left and right braces. And we can use simple and compound statements within our loops. So in this program, we have a for loop. We've got our variable count that we're initializing to 0. And as long as count is less than 10, we're going to perform our statements. What's a compound statement? It's enclosed in left and right braces. And so our statement is looking at the value of count and determining, is it odd or is it even? To do so, it uses the modulo operator, which gives us the remainder of a division. So if we divide 1 by 2, we get 0 remainder 1. That's an odd value. If we divide 2 by 2, we get 1 remainder 0. That's an even value. And so in this case, our program is going to loop from 0 to 9 to test whether or not values are odd or even and display a message. When we run the program, we see that 0's odd, 1's, or 0's even, 1's odd, and so on, just as we'd expect. When we work with loops, we have to be aware of infinite loops. That's a loop that never ends. And we get infinite loops because we have some kind of logic error within our code. Let's take a look at this program. In this case, we have a variable count. Our for loop is initializing count to 1 and saying, while count is greater than or equal to 0, do our statement. So 1 is greater than or equal to 0, so we print it. We then go up and do our increment portion. It makes 1, 2. 2 is still greater than or equal to 0, and we end it. And so in this case, our loop is going to repeat and repeat and repeat. And because count is always going to be greater than or equal to 0, our loop doesn't end. Now, we've learned that our integer value is only capable of storing values so high, and then the values become negative. And so, by luck, this infinite loop will finally end. But if we run this, we're going to see just a whole series of numbers as our loop kind of runs forever. And so you need to just be aware of infinite loops. They're some sign that you have some kind of logic error within your code. We've learned that a for loop consists of 3 parts: an initialization, a test, and an increment. And it turns out that we don't have to use all 3 parts in our code. In this case, we have a variable int that we've initialized to 0. So we don't need the initialization part. So we've left it blank. But we do have to put the semicolon that separates the initialization part from the test. And so in this case, our code's going to execute and display the corresponding values, but we didn't have to initialize it. Now we could move our initialization in there, but the key point of this is to know that parts of the for loop are optional. In the previous loops, we've initialized the value, we've tested it, and then we've incremented that value by 1. But with a for loop, we're not constrained to incrementing by 1. We can increment by 2, we can increment by 5, we can increment by 100. And so let's take a look at this program. It's got our variable count, which is kind of our loop control variable. It's initializing it to 0, and it's testing is count less than or equal to 10. If so, do the printf statement. Once that statement executes, we go and do the increment portion. But you can see in this case, we're incrementing count by 2. And so our test is going to go 0, 2, 4, 6, 8, 10. And then once it's 12, our loop will end. In our second for loop, we're doing something similar. We're looking at count equals 0 to count less than or equal to 100. But with each increment, we're incrementing by 5. Let's go ahead and run this program. And sure enough, we see our 0 through 10, and then we see our 0, 5, 10, 15 as we're doing our increments. So as you work with a for loop, you're not constrained to just incrementing or decrementing by 1. You can do whatever increment expression you need. You've learned that the semicolon marks the end of a statement. And there'll be times where you'll see the semicolon just by itself, nothing else. And programmers refer to that as a null statement. And so in this case, we have a loop, and it's using the variable count. Count equals 0, as long as count's less than 1,000. Just increment count. And we've got a null statement, so no processing is being performed. Years ago, programmers would do loops like this to just implement delays. But CPUs have gotten so fast that it's really hard to implement a delay this way. We'll see how to do a delay correctly in other lessons. But let's go ahead and run this program. And it should display a message that says I'm starting the loop, and then our loop will loop from 0 to 1,000, and then it should display a message, I'm ending the loop. And sure enough, it does. And so the null statement is just a semicolon by itself. Within a for loop, we're not constrained to looping on integer values. We saw that we could loop through the letters of the alphabet. We can also use floating point values within a loop. And so in this case, we're initializing a variable type float, the variable value, to 0.0. And as long as it's less than 10, we're incrementing it by 0.5. So you can see our increment portion has a floating point value. Within the loop, we're printing the value as a floating point. Let's go ahead and run this. And sure enough, we see our values incrementing by 0.5 until our loop's ending condition occurs. Now in the previous loop, we defined our loop's control variable outside of the loop. We'd say int count equals 0, or if we're using a floating point value, we'd 0.0. C allows us to declare our control variable within the loop itself. And so in this case, we've reduced our code a little bit, and so it says for count equals 0, and we didn't have a variable called count, so we're declaring the variable within our statement. As long as count's less than 10, print it and then increment it. And so you're going to see this format a lot because we only need a control variable as the loop's executing, so we should only declare the variable then. Let's go ahead and run this. And sure enough, we see the values 0 through 9. Programmers use the term scope to define the areas in a program where a variable is known. And so in the previous program, we saw that we could declare a variable within our loop. And so in this first program, we're declaring a variable called count. We're initializing it to 0, and then we're counting and displaying it as long as it's less than 10. Now we declared the variable within the for statement. And so that variable scope, where it's known, is limited to that for statement. After the loop ends, we try to print the variable's ending value. But that print statement, as we'll see, is referencing count, which is only known in the loop. It's not known outside the loop. So when we try to run this program, the C compiler gives us a syntax error saying, I don't know about count. We declared a variable called count, but its scope, where it was known, is restricted to the for loop. If we wanted to use the variable outside the loop, we have to declare it outside the loop. So in this case, we declare count prior to the for loop, then we declare a second count within the loop. Those two variables are different. The first one is known within the main program. The second one, its scope, where it's known, is restricted to the loop. So we initialize the outside count to 100. Then we declare a new count. It's only going to be known while the loop executes. And so it's going to loop through the values 0 through 10 and display them. And then after the loop ends, we're going to display the value of count to see what it is. So when we run this program, we see our values 0 through 10, and then we see our ending value is count. And so our scope here is two different variables, one that's known within main, one that's known within the loop. So C helps us avoid potential name conflicts by limiting scope. When we have a for loop, there may be times where we need to work with multiple values. Maybe we have a multi-dimensional array and we want to loop through the rows and the columns of the array. And so we can do that using C's comma operator. And the comma operator, in our first block above the code, we're declaring three variables, int A, int B, and C. So we've declared three variables on one statement, separating the variable names by commas. In the second statement, we're declaring three variables, A, B, and C, but we're initializing them to the values 1, 2, and 3. So this comma operator allows us to work with multiple variables on the same statement. And so in this case, within our for loop, we've got two variables that we're declaring. A, which we're initializing to 0, and B, which we're initializing to 100. And as long as A is less than or equal to 10, we're going to perform our statements. And so we're doing a printf statement that displays the value of A and the value of B. In our increment portion, we're incrementing both A and B. So you see the comma operator separating those two increments. So when we run this program, sure enough, we see that A gets incremented, B gets incremented, and so our comma operator allows us to do multiple things within the initialization part of the loop or within the increment part of the loop. And this will be common when we start working with multiple dimensional arrays. When we looked at conditional operators, specifically the switch statement, we learned that the break statement tells C to continue with the program that follows the current construct. We can use the break statement within a loop to break our loop end its processing. So let's take a look at this first example. We've got a variable called count. We're initializing it to 0. As long as count is less than or equal to 10, we want to do the statements of our loop. And within those statements, we see that we're printing the value of count, But then we've got if statement that says if count's equal to 5, break the loop's processing. When the break statement occurs, C will continue the program's execution at the first statement that follows the loop. Let's run this program, and sure enough, we see the values 0 through 5. Even though we rewind the loop less than or equal to 10, once we hit that break statement, we broke the loop. Now typically, you shouldn't use a break statement to end a loop. You use it for our error condition or something happened that's really bad and we need to break. But if you're finding yourself using the break statement, it's typically a symptom that you can rewrite your loop differently. And so our correct loop in this case should have been while count is less than or equal to 5. And so we can get an equivalent loop just by changing our condition. And so if you find yourself using a break statement with that loop, ask yourself, am I using it and I can rewrite the loop, or am I using it to handle some error exception? And there it might make sense to do. So just be cautious of the break statement within your loops. In C, the continue statement is similar to a break in that it changes our loop's processing. And what the continue statement tells us is stop processing these statements that are in the loop and go back and do the test again and see whether or not we continue the loop. And so in this case, we've got a loop that's looping count equals 0. As long as count is less than or equal to 10, do the test. But within our statement, we've got an if statement that says if count mod 2 is equal to 1. So we're testing if it's an odd value, I want you to continue. Otherwise, print the value. So we're going to print the even values. So when we have an even value, we print it. When we have an odd value, we say continue, go up and do the increment portion of the loop and then retest. And so when we run this program, we only see the even value. So our program's working. But again, continue is one of those statements that if you find yourself using it, you want to ask yourself, is there a better way to do this loop? And so in this case, there is. We can just kind of rewrite our logic. And so in this case, we're counting again 0 to 10, and we're looking, and we've changed our condition. So if count mod 2 is 0, which means it's an even value, just print the message. So we could do this without the continue statement. And when we run this code, we see the same output. And so if you find yourself using a continue statement, ask yourself, is there a better way to write this loop? So we learned when we looked at conditional processing that we should use indentation to make our programs easier to read. And the same is true when we're using a loop, whether it's a while loop, a for loop, or a do while loop. And so in our first program, we're looping through the values, trying to make a determination if the value is odd or even. But because we're not doing indentation, it's hard to tell what statements correspond to what. And so if we run this program, our program works. It's showing us all the even values as desired, but trying to read the program is difficult. A better solution is to indent our statements as shown here. So now we can tell which statement corresponds to the if, which statements correspond to the for, and which statements correspond to main. And again, if we run this program, we see our desired output, but our program is much more readable than its non-indented counterpart. So the for statement, the while statement, the do statement all allow us to repeat a number of statements. We can use all of them to increment to a value and display the value. The for statement's most commonly used when we're doing that kind of increment. A while loop is going to repeat its processing while a condition's true. And so this is the same while loop that we saw a minute ago that tests if the value even or odd and does something. Let's take a look at this code. We've got our loop controller, our count. As long as count is less than 10, we're going to perform the loop's processing. Our indentation makes it easy to tell what statements we're going to execute. And so we're looking, if count mod 2 is a true value, meaning it's not 0, then we know that we've got an odd value, so we print it. We then increment count, and we go up and test again. If count's still less than 10, do the statements. Increment, go up and test again. And so we're looping while the condition is true. Let's go ahead and run this. And sure enough, we see our odd values. Now we can use the while loop to loop through numbers like this or loop through letters, but in most cases we're going to use the for loop to do this. We'll use the while loop when we're not incrementing something. So when we want to read all the lines in a file, so while the value that's returned from our file read is not the end of the file, read the contents and display the contents. And so you can use each of the C for loops to do increment things, but typically you'll want to use the for loop. So determining which loop you should use when is critical to your programs. So we've learned that an infinite loop is a loop that never ends. And it turns out if we do 4 things, we'll generally avoid infinite loops. And I refer to those 4 things using the acronym ITEM. And what that stands for is initialize. We want to initialize our control variable, test the control variable, execute our code, and then modify the control variable. So we initialize, count is equal to 0. We test our control variable while count is less than 10. Then we have statements that we execute, and then we modify our control variable. So as long as we do those 4 things, we're typically going to avoid an infinite loop. Here's our program that does those 4 things. When we run it, we display the values and our loop ends. So you want to remember initialize, test, execute, and modify. It turns out that those are the 4 parts of our for loop. We initialize a variable, we test the variable, we execute our statements, and then we do our increment, so we modify. Now with the for and while loops, we do our tests, and if our test is true, we do the statements that follow. The do statement's different. It does the statements, and then it tests, should I do them again? And so a good use of the do statement would be to display a menu. So in this case, we're displaying a menu. If you type A, I'm going to say hello. If you type B, I'm going to say goodbye. If you type Q, I'm going to quit the program. And so we then read the user's response using the getChar function, and then we check to see what was that response. If it's A, say hello. If it's B, say goodbye. And we loop until the user has typed the Q for quit. And so the do statement's different from the for and the while in that it will always do the statements at least 1 time and then test to see whether or not they should repeat. Now years ago when we were programming with a Commodore 64 and things, we used a goto statement to implement our conditional and our iterative processing. And it turns out that the goto statement is still available in C. And so we try to avoid the goto statement because it can lead to code that's hard to read. We go to a distance a long ways away and we have to scroll through our code to figure out where we're going to. If we go to the wrong location, we get an error. But let's see how it works within C. To use goto, you define a label. And you do that by specifying a label name followed by a colon. And then you later go to that label. And so in this program, we're initializing the variable count to be equal to 0. And then we're displaying count's value. And if count's less than or equal to 10, we're using goto to branch back to that label so we can repeat our loop. So let's go ahead and run this. And sure enough, using our loop, we display the values 1 through 10. And so C has a goto statement. If you look really, really hard, and you'd have to look really, really hard, you might find a program that uses it. We typically try to avoid it because it can lead to programs that are difficult to read and maintain. So what are you going to learn next? To improve the readability of their code and reduce changes they may have to make in the future, C programmers often define constants and macros. And so we can see that we can define a constant to control how often we loop to a value, or we may use it to declare the size of an array that we're creating. And so in the next lesson, we're going to look at how we create constants, which is just a named value. So the first one, we're creating a name called size that has a value 25. Anytime we refer to size through our program, C will replace the name with the value 25. To tell other programmers that size is a constant definition, we put it in uppercase. Normally our variables are lowercase or mixed case, and so constants in C are typically uppercase. We'll also learn that we can define something called a macro, which is kind of like a function. And in this case, we're declaring one that's called square. It gets a value passed to it, and it's going to have the substitution of every time the program sees square x, it's going to replace it with x times x. A value times itself is a square. So we'll see how to create different types of macros in the next lesson.